This video will be an example of how to calculate standard deviation given a probability distribution, which is also part of section 9.4. The first step that you have to do is calculate your expected value. To do that, remember you're not just finding the average of your x's, you're going to have to use the expected value formula you learned in section 9.3 for probability distributions, which is to calculate expected value. You take each x times its respective probability. And then you add those values together. So you're just going to go down the line, take each x times the probability listed below it, and then calculate the sum. So the expected value for this data is 2.8. We can see that the probability of getting a 5 is the highest at 0.4, and so we should expect that our expected value, the number we should get as a value for x, should be close to the 5 versus, say, the negative 2, where our expected value or our probability of that is only 0.05. And so that's the least likely to occur, whereas 5 is the most likely to occur. So we should see that the expected value for our x's is being pulled closer to that 5. Remember, standard deviation is still the average distance. These x values are from being what's expected. So the standard deviation steps are going to begin in a similar way. So we're going to take each x, so we'll start with negative 2, and you subtract that expected value number. And once you have that subtraction answer, you're going to square those results to make them positive. So we get negative 4.8. Make sure on your calculators you're putting parentheses around that negative number so that the negative itself is taken twice. Otherwise, you might end up with negative numbers in your squared answers when they should all be positive at this point. After you have subtracted and squared, instead of going into an addition step with the other answers you're going to calculate, we actually bring back in the probability of that value of x occurring, and we multiply by that. So we're going to bring in that negative 2 has a probability of 0.05 of occurring, and we're going to multiply by that. And we get 1.152. We're now going to go to the next value of x, and we're going to repeat these same steps, but with the probability associated with the negative 1. So we'll take negative 1 minus our expected value. We will put that in parentheses and square so that we get a positive 14.44, to which we then multiply by the probability of a negative 1, which is the 0.15. And it gives us a total of 2.166. Next, we take 0, subtract the expected value of 2.8. We then square that result, giving us a positive 7.84. And we bring in the probability of getting 0 as a value, which is 0.25. And we multiply by that. And we get a 1.96. Bring in the 5. Subtract the expected value. Take our answer from the subtraction and square it. So 2.2 squared is 4.84, to which we then multiply by the probability of getting a 5, which was 0.4. And we get 1.936. And our final value of x is a 7. Subtract the expected value of 2.8, which is 4.2. Take that to the second power. You get 17.64, to which you then multiply by the probability of getting 7, which is 0.15. And that will give us 2.646. This row, or this column of multiplication answers that we have so far, is what gets added together. And we get an answer then of 9.86. 9.86 has a name. This is called your variance answer. And to get to square root, to get to standard deviation, you always square root variance. So if we take the square root of 9.86, that will give us our final answer. So our standard deviation for our probability distribution is approximately 3.1401. So this is the amount of spread associated with getting an expected value of 2.8 according to this probability distribution.